My name is Charlie Silber, and this is the Joule Thief. It consists of a 2N3904 NPN transistor, a 2.8 volt white LED, a 1 kilo ohm fixed resistor, two 100 microhenry fixed inductors, a AA battery holder, and a switch. The two inductors replace the hand-wound toroid used in the breadboard prototype and serve the same purpose of generating a magnetic field when current flows through them. When the transistor switches off, the collapsing magnetic field produces a high voltage pulse, which is used to power the LED from a low voltage battery, as shown here in Faraday's law. As you can see here, the LED is installed with its anode connected to the transistor's collector and its cathode to ground. The AA battery holder connects the positive and ground pads on the board. Before assembling the PCB device, first a circuit was built on breadboard. The first part of the circuit was we took two pieces of AWG copper wire. I took green and red, Christmas, twisted together, wrapped around a ferrite toroid core to form an inductor with approximately 8 to 10 turns. I have 9. The 4 stripped wire ends were then connected to the breadboard. As you can see here, I'm putting 2 right into the positive rail, 1 into the resistor, and 1 into the base of the transistor. The emitter terminal was connected directly to ground, as shown here. A white LED was added with its anode to the collector and its cathode to the ground. A used AA battery over here was placed into both power rails, 1 and 2. When powered, the transistor switched rapidly on and off, too fast for the human eye, creating voltage spikes throughout the magnetic flux in the toroid core. These spikes boosted the battery's voltage enough to power the LED. Here, one can see the difference between the PCB device and the huge breadboard circuit. Of course, there's a massive difference between the two, and it's very similar to the first project of voltage division. While they both hold the same purpose, this one is actually much more efficient in every way, shape, and form, and some aspects of it is unnecessary, such as the toroid ring, which is fully done by these two inductors. From this project, I learned about Faraday's law of electromagnetic induction, seeing how a changing magnetic field in the inductors could boost voltage to light an LED made the concept much more clear. It was a valuable way to connect theory with a working circuit.